Now let's discuss the second type, which is the frequency stability. So the frequency stability refers to the ability of the power system to maintain a steady state frequency after a severe system upset, resulting in a significant imbalance between generation and load. So simply, what does it mean? It means that the frequency stability means that our power system will reach a steady state value of a frequency. Okay, will reach a steady state value of frequency. The frequency will not having any oscillations. Okay, same as the rotor angle, it will reach a steady state value of the frequency here, same as a steady state value for the rotor angle. So the problem of the frequency stability, it's caused by the imbalance between generation and load. It depends on the ability to maintain or restore the equilibrium between the system generation and the load with the minimum loss of load. What does it mean? It means that our generator or our power system gives an amount of power, or gives an amount of S, or apparent power, according to our load. So if this load increases and our generator cannot satisfy this load, then the frequency of power system will start to decrease in order to satisfy this load. Okay, so in order to restore the original frequency, we will have to do something called the load shedding, which means that we are disconnecting some loads. So here the reason for the non-equilibrium is that the load, for example, is increasing, so our generators cannot satisfy this load, so the speed of the generator or the frequency of our power system will start to decrease due to the increase in load. Or the reverse can happen. If the loads are lost due to any, or loads are disconnected, then the frequency will start to increase. So in the two cases, we have to restore the equilibrium. We need the generation equal to the load at the power frequency which is acceptable for us. So as an example, to make it more clear, if we have a motor and connected to a load, and our motor, for example, is rotating with 1000 rpm, and if this mechanical load increases, then our motor speed will start to decrease, okay, in order to satisfy this load. Or we will have to increase the input power to the motor in order to give the same mechanical output power. So if the load increase, then the speed decreases, same as here in power system. As the loads increases, then the total frequency or the frequency of power system will start to decrease. Of course, when we are talking about the change in frequency, we are talking about a very large change in our loads. The instability here can occur in the form of a sustained frequency swings. Our frequency is varying with time. It is increasing, making some oscillations with time. These oscillations will cause our generators to trip, or the tripping of our loads, because our generators or loads does not accept this power swings or the frequency swings. The frequency stability can be classified into a short term, which means a short period of time in a few seconds due to the formation of an under-generated island, such that the frequency will decay rapidly, causing the blackout of the island. What does it mean? It means that the short time means for a few seconds. This means that our power system will be divided into islands. Each area will be alone. It will not be a grid connected to each other. It will be divided into island. Each island is alone, and this island will not be able to satisfy its load, so the frequency will decay fast, causing the blackout or the turning off of the electricity in our area. Okay, in case of the long term, which occurs in tens of seconds or several minutes, this will be caused by steam turbine over-speed controls or boiler reactor protection. For example, the speed turbine over-speed, when the loads are disconnected, then the frequency will increase or the speed of our generators will increase. So our speed over-speed controls will disconnect our generators. This is considered as a long term because our turbine controllers or the boiler reactor protection having a time constant very large. So that's why it's called a long term, due to the large time constant of these components. The grid having a specific frequency, for example a 50 hertz in my own country, or can be 60 hertz in other countries. For example 50 hertz, but it can be between 49.5 and 50.5 hertz. Okay, so we cannot increase above 50.5 or decrease below 49.5. The acceptable range for continuous operation is between 49.5 and 50.5. The system frequency can rise to 52 Hz or fall to 47 Hz in special cases. Of course, we cannot keep our power system in 52 Hz or 47 Hz. We have to adjust or make some adjustment in our power system in order to make it fall back in our range. Okay, but it can rise to this or fall to this in some cases. Okay, but not for a long time. What does the frequency instability causes? They cause, number one, the significant loss of generation, the significant loss of load, and splitting of our system into islands. Each island is alone and having its own load. Our power system is not connected again.